So the first thing about corrosion, like just to make it as simple as possible, right, is to see corrosion as what? A process of formation. Okay, it's a process. Okay, so that means it takes a while to happen. It's not like it happens immediately. So the metal might look like nothing is happening, but just give it time and you'll notice that corrosion has happened. So that's the first thing you need to notice. It's a process. It's a process of formation of the compound, a compound of pure metal by the chemical reaction between the metallic surface, take note of those terms, the metallic surface and its environment. So let me pick out the main phrases that matter to us right now. Number one, it's a pure metal. So it's not like the metal had any impurities in it. That's number one. Number
Mm.
two, it's a chemical reaction, right? That means in a large sense, it's not reversible. Okay, it's not reversible. Then the third phase that we have here is that it happens at the surface. Okay, so it doesn't really eat into the metal like that. But guess what? If it keeps on happening like that, if it keeps on eating into the metal, what will happen? After a while, the metal will um should I say disappear or something? Because it's
Rust.
reacting. Yes. So it's reacting. It just keeps on reacting and reacting and reacting till it's all used up. Okay. So that's the whole idea. So next thing that we need to understand is that it's an oxidation process. That means it takes place in the presence of what? Oxygen. Okay. And it leads to a loss of the metal because, as the metal is getting into the reaction, it's also depleting. Yes, that's the word I was looking for, depleting. Okay, so the next thing, the last concept, part of the concept is that hence disintegration of a metal by its surrounding chemicals through a chemical reaction on the surface of the metal is called corrosion. So just understand that there's something that's around the metal that's reacting with its surface, and that's what is causing the corrosion. Okay, so you mentioned rust, right? So that's what we have there as the first example. Formation of rust on the surface of iron, for instance. The second example is what? Formation of green film on the surface of copper. We'll find out what that green film is. But you know what happens. What causes rust? Do you remember?
Is it when uh some a metal mixes with is it I think it's air or oxygen or water.
Yes. So
Is it
remember,
oxygen?
yes, exactly, exactly. So there's a bit of water in the atmosphere, right? Water vapor, and then of course oxygen is playing its own part too. So everything comes into the mix. All right. So let's just keep going. Responsible
Wait, how
factors
does
for
you
corrosion.
see like
Yes.
apparently like painting, for example, like
Yes.
say like apparently like painting it stops rusting.
Yes. Yes. And the reason you can guess why, right? You know why that happens, right?
No.
So painting stops it or prevents it because painting creates a layer directly above the surface that's attacked by rusting. Do you understand now?
Mm,
So the thicker the paint, the more likely that the iron will be protected.
okay.
So where there is usually a problem is if there is a dent somewhere, maybe something hits on the paint and the paint just gave way and then exposed part of the metal, then that part that was exposed will start rusting over time. You got that?
Mm-hmm.
So that's why it's very important that immediately after a car is worked on, I'm just using a car as an example, the body of a car is worked on and they removed all the paint and all that. The usual is better to, it's advisable to immediately do a new paint job on the car so that rust doesn't set in. Okay, so the factors that we said for corrosion to happen, number one, the metal itself has to be there, environmental chemicals, temperature, and the design. Okay, so temperature also plays a role. So some temperatures make rusting happen faster. Okay, so um, let's just look at some basic things. Okay, so these are some theories of corrosion. I don't know if you might really need it, but so let's just see how they occur. Okay, so acid theory is one that suggests that corrosion of a metal is due to the presence of acids surrounding it. So this is just a theory, right? And we can prove it, of course, with the possibility of an experiment. So according to this theory, iron is corroded by atmospheric carbon dioxide, moisture, and what? Oxygen. Okay, so you can see all those things are in, I would say, abundant quantities around us. Moisture, oxygen, carbon dioxide. So um, you can see the product, okay, of corrosion. Iron itself is there. The H2O, if you look very well there, you will see H2O, that's water, then CO2, okay? So that's why
Mm.
you now have CO3 there. So, well, these are just possible products. So you can, but if you, however you look at it, you can see that those products have water involved somehow in it. Okay. All right. So these are chemical reactions. Well, you can leave these ones. They may look a bit complex for you to understand. But let's, like, on the surface, look at the concept. Now, this is the second theory. And now it's good to understand that these theories are what? They explain corrosion in a deeper fashion. Okay. So it makes you to understand what's really going on um, when we say corrosion is happening. According to this theory, for the chemical theory, corrosion on the surface of a metal is due to direct reaction of atmospheric gases like oxygen, halogens, oxides of sulfur, oxides of nitrogen, hydrogen sulfide, and fumes of chemicals with metal. And now this one, I'm not sure most people really hold up with this, but well, it's a theory, so that means it can happen. Okay. The extent of corrosion is of a particular metal depends on the chemical affinity of the metal towards the reactive gas. So I think this is the bit that makes it a bit um, dependent on reactivity series. And then oxygen, please take note of this last point. Oxygen is mainly responsible for the corrosion of most metallic substances when compared to other gases and chemicals. So
Mhm.
um, um, that's the gist of the matter. Oxidation, that's reaction with oxygen, corrosion by other gases, and liquid metal corrosion. I think this last one, you would be thinking of um, where water is involved. Yes, that's why they said liquid metal corrosion. Not exactly that there's, even though we know there's metal that can be liquid at room temperature, but that's not what we're talking about in this case. Okay, so corrosion by other gases, I think that permits CO2 to come into the mix. Okay, so um, so these are more uh, ideas that allude to the fact that of what we just said. Oxygen is the main thing. Some of the metals directly react with oxygen. Now, take note, the first time is in absence of moisture. And, uh, while we cannot say at any point in time there's oxygen in the air and there's no moisture, we cannot guarantee that. Uh-huh. But we're just saying that it's possible that the metals will just directly react with oxygen where there's no moisture involved. Okay. All right, so basic thing to understand is that when oxidation of a metal, just understand that oxidation just means addition of oxygen, okay? And remember, it only happens at the surface. It starts at the surface because that's where the metal is basically exposed to the air. The the core, the inner part of the metal is not exposed. So the oxygen can't get to it. Okay. So always remember that this thing is happening at the surface. So during oxidation of a metal, metal oxide, which is simply metal plus oxygen, the compound formed by metal combining with oxygen is formed as a thin film. Take note of that word, is thin. It's a thin film on the metallic surface, which now protects the metal from further corrosion. Or should we say it's it protects it temporarily, right, from further corrosion. Now, if diffusion of either oxygen or metal is across this layer, if diffusion happens. In other words, there's no guarantee that the oxygen can't make its way through that thin film that formed. That's why they said if diffusion is movement of a gas. So if diffusion is happens across this layer, further corrosion is what possible. So that's why painting is supposed to be the one-stop gap that will help us avoid corrosion as much as possible. And once corrosion has happened or rusting has happened, guess what we have to do first? You have to use maybe what they call sandpaper and totally clean the surface. Okay, why are we wiping off the surface? So that there's no space between the paint and the metal itself. So the paint is solely protecting the metal, nothing like, oh, I mean, there's something still hanging in there. No, it totally protects it. So the layer of metal oxide plays an important role in the process of corrosion. Okay, whether it aids it or it prevents it for a while, somehow it still plays an important role. Okay, so do you understand it? So you understand the concept so far, right?
Yes.
Okay. All right. So, oh, okay, okay. So this is now, we're now looking at, um, so I think this aspect, you may not really need this aspect because it's iron, right? Basically, iron that you are looking at. Did you guys discuss electrochemical, the possibility of electrochemicals have causing corrosion?
I don't think so.
No, okay, all right. So let's just keep it simple and as we look at only those ones. Okay, so I know this one's had a lot of slides, so it's not like I was planning to exhaust it, but yeah, I think it's just okay for us to talk about it that far. Okay, so you have any questions?
No.
Okay, so essentially, right? we've agreed to the fact that, excuse me, to the fact that what painting is the primary solution to what
So
avoiding rust.
preventing rust,
Yeah,
yeah.
yes, preventing rust. Okay, all right. So I said I was going to also uh give me a minute. Review, oh sorry, the slide that we talked about last time. Okay, all right. So you took pictures of these, right?
The last ones, yeah.
Okay. All right. So did you go through them on your own?
No, not yet.
You've not gone through them. When do you plan to go through them?
Today.
Today. Okay. Okay. So I wanted to suggest something to you. Um, since you guys don't have that, you guys are not giving your notes in class, is it possible that you have like a small jotter where whatever you write in class, you also write in that jotter. And then maybe anytime we're having class like this, you have something to refer to. You
Uh,
think it's something you can do?
okay, yeah.
Okay. So it doesn't have to be something that's, very conspicuous, something that would be noticeable by anybody. Just something that
Mm.
would be in your bag anytime you're in class. Simply make sure that anything you do in class, like you write down in class, you also write it down inside that jotter. Difference is the jotter goes back home with you. Your class note stays in school or with your teacher, whatever. I don't know what arrangement you guys have over there. So that way you have something that you can bank on and, to remember whatever it was that you talked about in class. So is it something that you can work towards getting this week?
Uh, I can ask my mom.
Okay. All right. Okay, so please try and do that. Maybe I might even talk to her too about it. So if you do ask her, then that would be like a reminder so she can help you get it. Something that's small. I think I'll need to emphasize that it's
Okay.
not so noticeable. Yeah. Okay, so yes, so quickly, let's just what were the things that we said here? I don't want to spend too much time on this. Physical properties, we talked about physical properties of metals, high what melting point and boiling point. And that's because of what? The forces of attraction between the positively charged ions and those delocalized electrons. Again, we said that there are exceptions. And what are the exceptions? Mercury and group 1 metals that have low melting and boiling points. Okay, mercury is a liquid at room temperature, which makes it very suitable for um, a liquid as for thermometers. Yes. Okay. And then we said metals are malleable. They can be bent to form shapes, different shapes, and they are ductile. That means they can be stretched to form wires. Okay. But then, of course, we know that some metals are better, have higher ductility, and are more given to being used in that fashion. Example, copper. That's why copper is used for producing wires. And then, yeah, okay. So that's explanation in blue, the blue text below is the explanation for why malleability and ductility can happen. The regular arrangement of the ions in layers means that they can easily slide over each other when a force is applied without breaking the bonds. Okay, so metals are really unique. So that's the shape, the structure that shows how that happens, the sliding over each other. Okay, Other properties of metals, good conductors of heat and electricity.
Mm-hmm.
Uh, yes, so you can see why they are a good conductor. The first one is explanation for electricity. Electricity is basically electrons carrying charges through a metal. If you don't have, if those electrons are not mobile, if they're not available, then there's no way a metal can be a good conductor of electricity. All right, so uh, good conductors of heat uh, is explained by the second paragraph there. When one end of a piece of metal is heated, positive ions vibrate more rigorously, and these ions transfer the energy. So that is just basically how the heat will be spreading through the metal, and before you know it, the whole metal is hot. Okay, showing that it's a good conductor of what? Heat.
He,
Okay. Yeah. So let's talk about density. Density, I told you, do you remember the formula I gave you for density? Do you remember the
mm,
formula? Mass per unit volume. Mass per unit volume. So, so per unit just means for one. So the mass of one volume, that's technically what mass per unit volume. The mass of that material that that can be found in a unit volume of that thing. So metals are tightly packed. So that makes their density to be what? High. Okay,
uh,
so of course you can see they are packed together as closely as possible. So in a unit volume of a metal, you are most likely going to have a high mass there. So that's why the density is high. Uh, uh,
wait, can you please write the formula on the screen so I can
okay,
take a
okay.
screenshot
All right.
with it as
Okay,
well?
sure. Okay. Okay. So I'll just say D, density. Don't worry, I think it's better if I type it. Density equals mass, um, let me see.
Wait, what is this?
Equal-
Is this wait? Is this what's the formula for again?
Sorry?
What's this formula for again?
The
Metals
density.
or the density of
Yeah,
a metal?
it's
Okay,
density of anything.
okay,
It's a general formula. Do you get?
yeah,
Hold on, I wanted to draw it line. Just give me a minute. I'm not done with the formula yet.
okay.
Where are we? Okay. All right, there we go. Okay. So this is what I wanted to do. Okay. All right. So that's it. It's a general formula. So whether metals or anything, it works. Okay. So are you good with that?
E okay, yeah, yeah, yeah.
Have
Okay.
you done the screenshot?
Wait, is the line like divide?
Yes, it's a division. Yes,
Okay.
that's it. Yes. Okay. All right. So, um, um, what was that? Okay. So we then talked about a little about alloys, emphasizing that an alloy is a mixture. Please remember, it's a mixture. It's not a reaction. It's not. There's no chemical combination between a metal and another metal or a metal and a non-metal. In this case, it's just a mixture. And a mixture means that it's like them sitting side by side, but then they are so together that they look like one. Okay, so that's why it's just a mixture. Okay. Other examples of mixture are like sand and salt, something that's just together, but they didn't react. Okay, so that's just the emphasis there. So that's why they still under physical properties. An alloy is a mixture of a metal with one or few other elements, that's metals or non-metals. Alloys are much stronger and harder than pure metal. So basically, an alloy is taking advantage of the two or more elements that combine to form it. So we saw that in okay, this is the reason. Different metals have different size of atoms, and these different sizes disrupt the orderly layers of atoms and makes it more difficult for the layers to slide over each other. So that means, in other words, ductility is kind of reduced. So in other words, there are sometimes we want to control even malleability and ductility in a metal. So because of that, alloys now come into the picture. Okay. And that's what we have. Alloys are harder and stronger than pure metals, which is a good thing in some applications. So these are examples of alloys. Steel is an alloy of iron and carbon, and stainless steel is an alloy of iron, carbon, nickel, and chromium. And of course, brass is an alloy of copper and zinc. And you can see it has this look of gold. It looks like gold just from the looks when it's clean. But you can still tell the difference that it is not gold. So the closest thing to gold when it comes to an alloy is that guy. Okay,
Mm.
so um So I think we basically covered those main concepts. So these are the
Wait,
questions.
so
Yeah.
so like what exactly
Mm.
is an alloy? Like is it just a metal or is it specific
It's
type
a
of metal?
mixture. It's a mixture of metals,
Oh,
of a
okay.
metal and a non-metal, or a metal and another metal.
Okay.
Yes. So it's better to just once you state it's a mixture, that word suffices for your definition. You don't need to add any other thing other than to explain, other than to say that it could be a metal that it's combining with, or another non-metal. So a pure metal and another pure metal mixture, a pure metal and a non-metal mixture, or a metal, another metal, and a non-metal somehow, in the mix, just to be able to achieve a stronger material. Okay. And you can even see that steel is used for making some things where, making some, doing building projects, things that you cannot use ordinary copper for, or you cannot use just iron for. When you need something that's reinforced, that's really strong, then you go for steel.
Okay.
All right. So these are the questions. I think you also screenshot this? Or okay,
Yeah, I don't.
I think you just answered them, right?
Yeah.
Okay. So
Wait,
by now, sure. Yes.
you see wait, what material is used for like what metal is used for like bridges and like building?
Okay. So steel will be a very good choice for
Mm.
buildings, for bridges, um, and now. So remember, there are times we need that strength of steel, and there are times we don't need it. So for instance, for building the bodies of airplanes, right? I think we use mostly airplanes use something that's light but strong at the same time. So aluminum lends itself to that, in that category. Um, um, yes. So that's basically it. So
Oh.
so yes, it's basically a
And
choice
then
of what you really need for a particular
and then
application.
wait, so then what material would you use for a car? Iron.
Mm, mm. So yes, so cars now are a combination of different materials. you need them to be fast, so you need them to be light at the same time. So some cars use fiber, I think it's fiber, I'm not sure now, fiberglass, but yes, there's still a place for iron in the engine. Of course, those
Why?
are places where there's heat because of the heat. Okay, so the body
Okay.
of the car can, have something that's a bit lighter, but the engine, where there's high heat, it needs to, like withstand heat and all that. You need iron there.
Okay.
Yes. Okay. So if you have some other questions, you could put them on the group, and I'll do my best to answer. I just don't want the system to go off on us when we're still in the meeting.
Okay. Okay.
Mm, mm. Okay, so if I think we can um, end here for today. Okay, so your test will be in the morning, right?
Yeah.
Okay. All right. So I wish you the best. I'll be looking forward to hearing from you on how it went.
Okay.
All right.
Thank you.
All right. Bye.
Bye.